Good morning, everyone. Uh, I see here around 180 participants. We have somewhere registrations around 200. Let's just wait for another minute before we can begin. Good afternoon. Good morning. They're all participants from various time zones. Thank you very much for being here. Okay, here we go. So as I said, I welcome each and every one of you for the webinar on BACnet Secure Connect. Thank you very much for taking your precious time out for this webinar. Now the specification was out for BACnet Secure Connect way back. There's a lot of materials and literature already there. But as Softdel, as a company, we really wanted to come up with this webinar once we had the product tried and tested. And that's what we are here today. We do have our product done and the confidence comes and hence the webinar. So I welcome you all. I am Vishal Rathod, your host for today. With me is my colleague Siddharth Sinha, who shall take us deeper into the subject of BACnet SC. So before we start a session, I would like to take you a bit. I'll just take 1 minute of yours about Softdel. So Softdel was established in 1999. That is 20 plus years of focused work in building and industrial automation. We have our offices in US, Japan, and India. The main engineering center is in India. Our offerings primarily we offer convergence suite. So that is basically packaged solution stacks, tools, licensed IP, and simulation softwares in one package. We have digital services on offering, which is platform services, platform engineering, enterprise application, AI/ML solutions. And then we have product engineering services, which is pertaining to the device hardware development, firmware development. And lastly, the most important point, Softdel has a world's first BACnet lab, which is backed by BACnet International. It's fair enough to say that in about 90% of the world devices come here for certification. This is the lab where the devices come, and it is with BACnet International that we test these devices and get certified. So I'll say that we take pride in saying that we are in a very niche domain of connecting devices, enterprise, and people. So thanks for your patience in listening about Softdel. We'll move on to the agenda. Right. So now with BACnet SC, I'm sure this journey of yours would have also started, and hence we see your participation. There are multiple questions that might arise in your mind as to what happens to my legacy systems, which is a BACnet stack already there. How do I configure it? What are the topologies, that's possible? Fail safe, BBMD, those kind of advanced topics. We'll try to do justice to give you as much of information as possible. Hence, we have divided the overall session in 3 parts. The first part is diving much deeper into the technical aspects of BACnet SC, right from what is BACnet SC, the architectures, the possible architectures that can be there in the field, and then eventually we'll move on to the demo. Now, this demo is kind of a live demo where we'll be actually configuring and showing you the node and the functioning aspects of it. And then the last portion is Q&A. So I'll really recommend and encourage you to write down your questions in the Q&A sections below. We'll be taking up it in the last 15 minutes. With that, I'll hand it over to my colleague, Siddharth. He'll start with the BACnet SC overview.
Thanks, Vishal. Thank you everyone for joining today. I am Siddharth Sinha, Director of Product Management of Softdel. With me, I have Manoj Kotnala. He's a Senior Technical Architect for BACnet and BACnet SC. And also with me, Milind Vaidya, who is a software developer for BACnet SC. So he is going to demo end-to-end workflow for SC, how we are connecting node to hub and all the direct connections. Okay, so let's get started. Before we start with BACnet Secure Connect, I would like to talk about more on BACnet. And so I hope everyone who has joined this session today pretty much familiar with BACnet, and there could be a probability that some new member has joined today as well. So BACnet stands for Building Automation Control Network Protocol, which is a standard communication protocol, was introduced by ASTRAE long back in 1995. So when it was introduced, in that time, using TCP/IP protocol or using the same thing, making a device which is basically commonly used for building automation network was a bit expensive, and also kind of other feasibilities was not there. So now BACnet evolved over the time, and it evolves with respect to the protocol revisions, where we have added where ASTRAE and the governing body adds basically different parameters, properties, attributes, and then kind of changes in the data link layer we have seen. We started with MSTP, then Ethernet, and then IP. So now in today's world, almost everyone is using BACnet IP device or controller in the BA domain, and so it is using TCP/IP or IP infrastructure. But the actual scenario is we do have using the building IT network, but we do have two separate kind of network, two separate network, but infrastructure is almost the same. Now, if I wanted to make two things in parallel, and then of course we do have some challenges, because the current implementation what we have right now, it has some limitations. So we want to make a little friendly the BACnet IP communication, so that IT network and BA network can coexist, and we can have seamless communication. So challenges are or limitations are kind of, the first is it's not standard. So the configurations or specification whatever we have right now is not comply with the IT standard. So like managing from the IT department or IT engineer is a little challenging. And then the communication is not secure. So here we are using UDP, and so that's the reason it is not secure, and kind of in entire secure network we have one component of it which is not secure, and another one is like complexity while we are transferring or sending or forwarding messages from one network to another network. So with all these limitations, ASTRAE introduced one new thing, which is BACnet Secure Connect. So what is BACnet Secure Connect? It's a simple secure data link layer. So why it is simple data link layer? Because we have not done anything in the entire stack. So whatever you have till the data link for IP, it is as it is, and this is kind of another data link we are porting, or we are just adding into on bottom of it. So there is no major changes in respect to in other things, but this is simple kind of new addition of another secure data link layer. And let's look at the features, because this is going to resolve or solve all the challenges whatever we have today with respect to BACnet IP implementation. And so it is using a WebSocket communication, which uses also a transport layer security, TLS 1.3, and which provides a secure communication. So one is done. Okay, you have now secure communication. Now the second is the complexity of broadcasting things. So when you have a complex network, you need to have multiple subnetworks or internetwork. In that case, you need a device which is called BACnet IP broadcast management device, and also you need a configuration. So this is another thing being added as a feature, so that you do not need to configure BBMD devices, and also you do not need BBMD devices. So you are eliminating BBMD devices as well as the configuration. We are making things simple. And also how we are making things simple, because it supports DHCP as well as DNS hostname. So it basically supports create a dynamic IP so that you can extend your entire network. You can make simple things. You can eliminate all complex things from out of it. So these are the things being added as a feature. And then if you look at it, the address part, when we are doing who is I am kind of things between the two devices. Now here we are using the standard NAT. So standard NAT helps you to have seamless communication across the network. So this is another thing as a feature being added. And then also, we are moving from UTP to TCP, and the TCP is kind of data transfer protocol here in SC and in the Secure Connect. And then the most important and interesting thing is, though it is a new data link layer, but kind of it is going to have a full compatibility with your existing network while doing the routing. So we'll explain more on that later in our slides. But this is okay, if you have your existing network, it's fine. You can extend your existing BA network with adding SC network as well. Now, moving from next slide, which is basically BACnet Secure Connect specifications. And we talked about now secure communication is there and how we are achieving it. So web socket communication, which is basically a port using transport layer security, which is basically a successor of SSL, which is nothing but a kind of cryptographic protocol where you have computing devices, 2 or more in the same network, so that you can send a secure messages from one networking devices or one computer devices to another computer devices. So that's one of the key things we are using for Secure Connect. Now, second is authentication and authorization. So as of now, we do have a basic authorization and basic authorization. So which means every devices in your network needs to be authenticated. Means when establishing communication, somehow every device needs to be authenticated. So this is another things we are doing as a in the BACnet SC. Now we talked about it supports NAT, network address translation, and then the new data link layer which has been added as a Secure Connect is protocol revision independent. So whatever protocol revision you have, irrespective of that, you can implement it or you can upgrade it, and which means it's basically encourage early adoption. So removing all the complexity with all other things, the porting or upgrading making pretty simple for here. Now in the parameter, you have seen we are using security parameters since long. Now security parameters been renamed as a data attributes, and data attributes basically helps you to carry the extra data along with your application as well as network data. So it basically got the capability to carry extra data along with APD and NPD messages. It supports DNS hostname and resolution and DHCP, and then also it supports static and dynamic IP. It's or you can go for static IP or you can go for dynamic IP as well. Now TCP as a transport protocol. So here we are using TCP in place of UDP. And then we talked about the basic authorization part. So now the ASTRAE or the governing body is basically moving to the next level. So okay, this is fair enough. We have general authentication or basic authorization in place. Now what could be the next thing? So next thing could be a ACE OAuth framework. So ACE stands for authorization for constrained environment. And I will explain a little bit on this because so OAuth is kind of an authorization framework or schema in current internet today. Okay, in the internet world, we are using OAuth. So OAuth got multiple version, 1.0, 2.0. So there are multiple versions, but basically OAuth is three-party kind of framework where you can access, or you can the access can be granted without providing your secure data, like any credentials, your password or anything which is pretty much confidential. You do not need to pass that information, but access can be granted. So now OAuth 1.0 using their own security communication or topology from OAuth 1.0 to 2.0. So they are also using TLS as a kind of component, and it has also application called access token. So you can have access token to get this authentication done. Now from moving to OAuth 2.0 to ACU OAuth framework. So this is, so OAuth 2.0 or OAuth is kind of like framework for entire internet world, which is huge. And if you look at the building automation, of course, a little bit like tiny or small with respect to the entire internet world. So somehow the network security operating group is working on something which is pretty much like can be adaptable at the BA domain or building automation domain. So NSWG is working on it, and probably this could be the next level of authentication. And this is very interesting framework because it has some concept which is very much friendly with the building automation domain. So it can offline token validation can be done. You can do token caching. You can do kind of like an authorization hint. So these are the very important feature because there are multiple requests and services are going on between the two devices all the time. So you are sending some information to another devices. You are asking someone to change the set point of the temperature of any other things. So these concepts related to ACU auth is going to help pretty much to implement as a next level of authorization. Now, what is a BACnet Secure Connect architecture? So it has hub and spoke model or hub and spoke topology, where you can have one device, which is basically hub, is going to connect another device, which is basically node. And hub is going to help or forward messages from one node to another node, or you can make it simple from one devices to another devices. Now, how things are going to happen. So basically what hub does. So it's a very simple for hub. So hub simply forward messages from one devices to another devices. You can consider these as a simple routing function. And then the interesting thing is you can add additional or more functions along with hub. So you can add hub with node, you can have hub with routing or router, something like that. So you can make a combination of a couple of things. And then another important aspects in one network, even you can call it as a sub network or whatever, only one hub can reside. So this is overall about the hub. Now, what are the examples of hub? So hub can be supervisory software, kind of BOD profile kind of thing. It can be a supervisory controller, and along with node, and then also routing software just simply hosted in the cloud. So this is extended from what we are doing in classic BACnet or in classic BMS. Now, what node does? So node basically sends messages from node to hub, and node also sends or forward messages directly from one node to another node. And in one network, you can have multiple nodes. And examples for node is like, it could be equipment controller or plant controller. It could be a field devices or IP to SC or MSTP to SC router. Now, BACnet Secure Connect also supports a failover architecture. So it's kind of like, the same topology. We have hub and spoke topology, but in case primary hub fails, then failover hub basically, take it out from that point. So now how things are happening. So there is a component called hub connector in the node, which initiates like, two function. One is like, primary hub function as well as failover hub function. And so when node can see that, primary hub is down, so that initiation, whatever hub connector made to connect the failover hub is being connected. So this is a simple thing. Node will check if primary hub is alive or not. If it is not, then node will directly send the messages to the failover hub. Now, failover hub is of course like the same as primary hub, and along with node, you can have supervisory controller, supervisory software, as well as routing software. Now, let's look at the advantage of our classic BACnet. So a lot of things been added in Secure Connect as a feature or as a functionality, and what benefits we are getting out of it. So first of all, we made things secured. So which means you can put into the same network where a building IT network lies. And now everything can be managed from an admin, like, there could be IT help desk or IP admin department who can handle everything from their point of view. So this is the one thing. So shared and managed, both can be done in the Secure Connect part. Now, next thing is, okay, now this is pretty much secure, and of course you can put it into the same network, and you can also share your application, exchange your data, exchange your information along with another application or another network in the same IT infrastructure. Now, one is security and another one is privacy. So BACnet also got some their own value, which could be related to proprietary, attribute, objective, or all objects or all other things, and as well as the entire workflow. So you can also keep privacy of entire BA domain specification or protocols with respect to device discovery and all other things that can also be taken care through this. Now, we talked about that, we have eliminated BBMD and the configuration and how we are going to benefit it. So let's say it's a complex network, huge network, multiple sub network is there. So it is always difficult to configure each and every BBMD devices along with foreign devices and all other things. And you might face some issues or error while any system engineer is going to configure BBMD configuration or device configuration. So you are eliminating the entire thing. So you are making the entire workflow or communication is pretty simple, and which is also basically preventing the BBMD BBMD broadcast storm. So now the entire communication is seamless across the network, removing all the complexities with respect to multiple BBMD devices, which is basically representing different sub network along with their configuration, and also a bunch of messages forwarded from one network to another network. This is going to be pretty much prevented. And it also uses standard NAT, so seamless communication. So address resolution is becoming easy in this case, and you can have more quick communication being established, less error with respect to response or acknowledgement. So this is pretty much seamless communication. Now, if we have BA network separate from the building IT network, and if you want to extend it, you might need to have a lot of things to do it. So now it is of course in one network. So if you want to extend that network to create any enterprise level applications, that can be easily achieved from here or through BACnet. Now, a lot of enhancement been done. So at the end of the day, as an outcome, you can save a lot of money. So the entire architecture is cost effective. So now let's look at the example. So this is BACnet S2TSC architecture. And if you look at the example on the slide, we are trying to show how message forwarding path is from one device, BACnet one device, which is basically residing in one network to another network. Now, if you look at device A, which is basically BACnet SC node, and let's assume it has a client profile. So client profile means kind of like, supervisory activity is being done through this device. Now, device A is going to send information to BACnet SC hub, which is also residing in the same network. And then hub is going to send the information to SC to SC router. SC to SC router is going to send another SC hub, which is also residing in another network. And then at the at end, server B, which is basically device B, is going to receive that messages. So so B got server profile. So let's consider this as a controller or thermostat or network sensor, something like that. Now, interesting thing is you can see, you can choose one AC to SC router, and you can have 2 port, and you can add node along with the router. So apart from routing, you can also execute other things as well. Now, we also talked about AC architecture, where we are eliminating BBMD and how it look like when we are eliminating BBMD. So so we have shown 2 examples. One is let's say you have network A, network B, network C, having different profile, different devices. Now, one way is devices from network A and network B and network C can connect to one centralized located hub plus router, so that you can send direct messages as well. So you can send, you can forward the messages to the hub, as well as hub can forward or route that message to another network. So that's one way of doing it. Another way of doing it, okay, you can have one dedicated hub for each network. So you have network A, network B, network C, and then you just send the messages or forward the messages to the hub, and hub is going to send to the SC-based router. So these are the 2 ways. We wanted to make simple, how we are eliminating BBMD. So what would be the architecture in that case? Now, at the very beginning, we talk about the backward compatibility. It's pretty much you can do early adoption if you have your existing network, and you can also do retrofit phase by phase. So this is one of the way where we wanted to show through an example how message forwarding path is from one SC node or device A to another device B, which is basically IP device. So same like previous slide, we have one device, which is node device, having client profile, sending messages to SC hub in the same network. And then SC hub is sending messages to the router, which is SC to IP router. And then that router is basically sending messages to the IP devices. And all other parameters you need to show. We have tried to show in a couple of examples over here, kind of BACnet network number, you need to put BMAC, also you need to put all of the associated IP addresses for device B. And so we have shown SC to IP. Now this is SC to MSTP routing. So again, node A, which is the client A, is sending messages to SC hub, and then SC hub is basically sending messages to another router. Now here is the difference. Here you have SC to MSTP router and router with node, and then that router is going to send the messages to MSTP devices, and the green kind of indication is shown how the message is flowing from node to MSTP devices. Okay, now the next part is certificate management in BACnet SC. So we are going to show basic authorization part, like the device authentication workflow. So let's assume you have existing network where you have node A and node B connected to the hub, and you can simply show this as hub, or you can show node plus hub. Both are okay. And for these, you need some prerequisites piece of stuff. So to establish the communication. So one is private key, public key, and as well as CA certificate. So both have like node B and node B, both have all the three things. So they are easily connected to hub. Now let's assume you have new device, which is factory default device or factory reset device or kind of fresh device, new device been introduced into this network. Now this device does not have anything. So it does not have private key, it does not have public key as well as CA certificate. Now see whether it is going to connect with hub or not. No. So node has to be authenticated to the network, and after that it can establish a secure communication with the hub. So how we are going to achieve this for this factory default node device? Okay, so this is a node which is having nothing. Now there are two ways. One is a node can generate itself their key pair. So key pair basically used for message encryption as well as decryption, or you can have a config tool, which is basically a certificate config tool, and through certificate config tool you can also generate private key and public key. Now if you look at the example on slide, so private key is having a kind of green status, but one is like in yellow and one is in red. So though we have generated the public key, but it's not been signed through a trusted CA. Also, it has not been installed any CA certificate. So we need to do one step further. So next step is like, now config tool or certificate configuration tool is going to send a certificate signing request to an authority. So that could be an intermediate CA or root CA from the same network. And then you can have both the things which was left over in previous step. So you can have now public key with signed trusted CA, and you can have also CA certificate installed in the node device. Now let's see how it looks like. So now you can see all of the status are green. Now go to the network. So this is the existing network, and this is the new device which is having all three things. And now yes, now factory default device can set up establish a communication with the hub, which is secure communication. So this is the basic authorization, and of course the governing body is working on the next step. What could be the next step for this entire authorization workflow or authentication workflow? So next step is BACnet SC demo. And so these are the things we are going to cover during our demo. So one is like, we are going to show you a quick overview how we have done the setup, and then also how you can do the basic configuration for node and hub, and then the connection part, like request and accept. And also we are going to show some services things. So like read write services, A side can initiate and B side can execute it. So read write, read service initiation as well as service execution. And then two things we are going to show you, we are going to demonstrate you. One is advertisement solicitation, which is basically an arrangement so that message can be received by the requesting node. And then advertisement, which is basically providing configuration and status of the source code. Okay, over to Milind.
Thank you so much, Siddharth. So I'll just directly jump into our demo setup. So what we have today, so if I need to just sum up in one line what we are going to show today, so it is this line, that BACnet SC nodes communication through hub. That is what we are going to achieve today. So who are these SC nodes today? So node A and node B. So you will see me talking like node A wants to communicate with node B and like that in this demonstration. So I have divided this into 4 subparts. So basically, first thing we will do is configuration. I've listed here important configuration, like one may have device. What is the device instance for the node? What is the VMAC for the node? On what URI this node A will be getting connected. So all this configuration and remaining configuration we'll see when we'll see that node config file in detail. After that, second part will be primary hub connection. Obviously, to communicate, we'll need whenever every node initiates, it will start with doing primary hub connection, and then it will proceed. So we'll see that as well here in our demo. There will be node A, node B, and node C is also present itself in hub. So all these 3 nodes will be connected to hub as a primary hub connection. So that we will achieve here. Then the third part is BACnet services. So we'll do RP, WP, or GUIs, basic BACnet services. So mostly our flow will be like, suppose node A has requested RP services. So it will get forwarded, it will be get transferred to the hub. Then hub will forward that request to the destination node, which is node B here. Then I'm considering a positive scenario here. So for positive scenario, node B will give acknowledgement, which will go to hub, and hub will in last forward that acknowledgement back to the source, which is node A here. So you will see in those Wireshark logs that every request is having 2 copies in this Wireshark log. So that is nothing but one will represent node A is traveling to hub, and second one will represent hub forwarding to the destination node. So that you will see. And the last part, the SC specific messages. There are some SC specific messages, advertisement, solicitation. This is a bit tongue twister, but I've managed right now. So it's like, suppose node A wants to communicate that what is the status of node B, whether it is connected to primary hub, whether it is connected to failover hub, or whether it supports direct connection. So something like that. For that, these message will be shared. They also will follow the same path. So that is for our demo setup. First thing first, we'll just start with configuration of our node A and B. So for that, this is the configuration file. So you will see majorly this configuration file is divided into 2 parts. The upper parts is mostly about BACnet related properties. Like here you can see device instance is mentioned, device name is mentioned, UUID is provided. So we can configure these properties over here. And the second part is SC properties. So most importantly, you have to give primary hub URI. So this is the URI where your hub is listening, and we need to provide that URI that which will be your primary hub. So we have configured here. Similarly, you can configure your failover hub URI. Then do you want hub as well with your node in your configuration? For now, I have made it false. I just want node for this demonstration. Then if you want the direct connection enable or disable, that you can mention over here, and their URIs also you can mention. Then important part is VMAC. So VMAC is mostly used in our communication. So here I have mentioned all 3s for node A. Then I have made node enable, these versions. And just now in initial part of the webinar, we have discussed that we'll need these key pairs and certificates. So these certificates have already configured here. So private key and then operational certificate is nothing but our public key. And these have given the full route and interchange path of this CA certificates, whether it is intermediate CA or root CA who has signed this public key for me. So I've given all these certificates also here. And here are some of the additional parameters like connection wait time. So here, suppose after what time you want to retry the connection. Something like configuration also you can give in 10 seconds, for example, here I've given. Same for the disconnection wait time. And third thing is heartbeat timeout. So basically, whenever our node is getting connected in the connected state, so we can give a predetermined, a specified time. So after that time, node will share heartbeat with our hub, or we can say exchange heartbeats with the hub just to ensure that our connection is alive. So that I have mentioned here 300 seconds. So that's all. That is what required configuration for node A for now for our demonstration. Similar things I have done for node B. You can see all these similarities here. So what things changed? So I've changed UUID here, device instance name I've changed here, and then important parameter VMAC I've made all 4 for node B. So our node A is all 3, our node B is all 4. That is what we have configured. So configuration is done. So let's go and start our node itself. So I don't want log here, so I'll continue with this. So yes, so first thing I have noticed here is yes, the current state is connected. So we'll just go through the logs here. So first thing, we have discussed now the configuration. So here it is exactly the same, that configuration we have notified here. After that, the first thing, whenever node started, it will do the attempt to its attempt to connect primary hub connection. So he has started and crossing the various states. You can see this awaiting accept state and awaiting WebSocket state, crossing all those states. In the end, it has got in the connected state. So our node is now connected with hub. So we'll do the same thing for node B as well. So node B also got connected. So let's check just once on Wireshark, what Wireshark captured. So here we can see that connect request is from all 3. That is our node A. He has sent the connect request. Similar connect request we can see from all 4, which is our node B. So if we go into detail, so whatever in payload, he's sending that yes, I'm 3333. Please allow me to connect. This is connect request sent to hub, and hub also accepted for both of these requests. So we got our hub connection successfully. So let's now just split our screen with a better vision. Yes. So this is our node A and this is our node B. So we'll go to our third part, that is BACnet services. So we can start with RP, but before going with RP, I just wanted to do who is to check that whether node B is present in the network. So I'll be using this command for here now. So I'm calling this, then broadcast. I want all devices. So here I can see that yes, there are 2 devices present, so I can communicate with them. So now let's come to RP property. So now device A wants to read the device name of node B, device name, device object of node B. So we just need to configure our RP request. So that we can do from 2 ways. One is the command line, second is the CSV file. So I'll just quickly go with the CSV file route right now. So I'll just configure this. Yes. So here 2 parts of CSV file. First part is about our destination node addressing that we'll do. So I have mentioned here what is my source node is, which is 33, what is destination node is. Then I have provided my destination VMAC, that is all 4. That is our device B, that is node B, and in the end related to read property. So we have given that object type 8 and 77, that is our device property, and we are going to read the device name of that device property. So that I have mentioned here. So let's just go into our node again. So we have already configured this using the CSV file. So I wanted to read device name of node B. So I'll use this read property here. So here I'm getting this default name, that BACnet SC device. So I would like to write something about this device name of node B. So what I'll do is I'll use similar write property request from node A. So as we discussed, initial configuration will be same because my destination is exactly same for now, that is node B. So just think what I'll change is I just wanted some meaningful node name. Here I'll just make this Softdel as my device name. Softdel node is what my name is, so I'll provide it. So let's now write that in our node. So here I'm writing that using same CSV file, just to be configured. So here I am getting that my request is sent successfully, and I have received simple ACK as well. You can see here also that node B has received a request and he has sent the response, which I also received acknowledgement. So now my device B's name got changed to Softdel node. So let's check that with read property again. So we have already configured read property through CSV file, so we can directly go to the read property here. So here now our device name is changed, Softdel node. So that is what I wanted to show our RP services. So let's check one more time the Wireshark, what he has captured over here. So we were here till connect accept, then I've done who is, for that 11 and 44 responded. Then I've done this read property. So here you can see, as I've discussed, there will be two confirm requests. One is traveling from node A to hub. The second one is traveling from hub to destination node, that is node B. So here also you can see destination virtual address is mentioned as all fours. Then similarly, we have two acknowledgement, same way, the node B to hub and hub to node B. So that is 4 message packet for every property. So here we read those from node B, then we have written for Softdel node, and then we have checked back again using read properties. So these are the logs for the same. So that is from the third part. And now the last part, that is SC related message. So there are a few SC related message also they have provided, like advertisement solicitation message. So I'll just quickly call advertisement solicitation message from node A. So he's asking me the destination VMAC, what you want. So I am providing it destination VMAC as all fours. So here he has sent that advertisement solicitation message successfully, and we have received also their response as an advertisement message. So just quickly we'll see this on Wireshark. Thus yes, that is sent over destination virtual address as a all fours, and in response what that node B has provided is that I'm connected to a primary hub right now, and yes, I accept the direct connection. So if you wish to talk to me one-to-one, you can request a direct connection. I will provide the service. So here he is mentioning that as well, and what will be my maximum VLC length, what will be my maximum NPDU length, that also he has mentioned. So that is from advertisement part. We have given enough opportunity for node A. So let's just put one more message for node B as well. So I'll just send advertisement message from node B to node A. Sorry, I provided a wrong address. So let's try it again. So here now for node B, I am providing all three VMAC, that is destination VMAC for node A. So here also I've sent successfully the request. You can see it is received over here. Then he has sent this response, and you can see this exactly the same response we received here. So that's it from my side. Thank you from my side, and over to you, Siddharth.
So thanks, Milind. And okay, so let's talk about Softdel's BACnet stack. So I thought it's a good opportunity to give you an overview what we have in our product bucket. And so we do have both the things, BACnet IP for OS and BACnet IP and MSTP for RTOS and embedded system. And these are the multiple profiles supporting Linux and Windows available with multiple protocol revisions, as well as for MSTP and IP devices. So you can reach out to us if you have any requirement on this. Now, quick highlights on Secure Connect. Secure Connect will be available February 2022 onwards, and you can have all profiles along with Secure Connect. If you want to upgrade the services, you can also have, if you want to upgrade your existing stack with SC, that can also be done. And also the other things, which is Prime offering. So I'll ask Vishal to talk about a little bit on this.
Okay, thanks for that. So before we move on to QA sessions, the time is running out, but I'll make it very fast. That we have industry leading program, which is called Softdel Prime. That is kind of a suite for stacks, tools, services, consultancy, training, all packed in together to accelerate your solutioning, architecting in the BACnet domain. So do let us know. Do check our website for more details. We have it all listed there. Moving on to question and answers, we have first question. Siddharth, I would like you to answer. If some vendors want to replace old BACnet device with BACnet SC, what will be their procedure?
Okay, so it has a couple of steps. So one is like, you can go for step-by-step upgradation or step-by-step retrofit, or you can do a kind of like, entire things into the SC. So entire things into the SC, I think I do not see that would be the practical approach. Otherwise, what you can do, let's assume you have a mix of MSTP and IP network. So what you can do, like you can use MSTP to SC router, so that you can connect that the entire MSTP network to the AC network, and also you can use IP to AC network to connect your IP network with the AC network. But there is a challenge, like if someone got the capability to hook up or plug in into any MSTP devices, then that is still unsecured. So but yes, this is one arrangement can be done, and this it is always recommended to go phase by phase upgradation, so that there should not be any impact on the operation, but as well as you can upgrade your entire things to SC.
Thanks for that. The topic is quite vast, and so are the questions. So the next one again goes about primary hub URI contains IP address. Earlier, it was informed that we can rely on DHCP IP assignment. But then the participant wants to know, how can we rely on DHCP IP assignments when it was said that it's being used? So yeah, over to you, Siddharth.
Okay, so if I understood correctly, yes, of course, it's a dynamic thing. There could be a possibility to change the IP address. But we have talked about two things. One is like domain name resolutions and DHCP. So in place of IP, you can put DNS, so that that is the possible way to do it. not to change like IP things, and also we can set up a stable communication between node and hub.
Got it. Yeah. Okay. The next question, interesting about the platform. Does the software work on Linux platform? What is the memory requirements to host your application on embedded platform?
It does support Linux platform. Of course, it does support Linux platform, and we have been doing this for IP MSTP as well. Sorry, for IP as well. And answering your question is yes. Memory thing is not dependent on the SC. It depends on how many object is going to be supported for that particular profile. So when you choose the profile, whether it is a AAC profile or ASC profile or BBC profile, you also need to kind of like take all other objects, whether you are going with a set of 60 objects, 30 objects, or 20 objects with respect to your protocol deviation you are looking for. So that is the one thing, that is the one aspect. And then second one is like, what are the services you require? You would need the entire services, or you need a couple of the services. So there is a calculative method to work on that part. So once you have the requirement, your requirement is pretty much clear that, okay, I need this profile, I need this much of object and this much of services, then you can calculate the memory part for embedded things.
The next one is, does BACnet SC accept certificates generated by me, or they need to be bought from CA companies and then signed and given to the customers?
Yes, you can do that.
Okay, great. I think we have not many questions, but probably Siddharth, you can pack in one last.
Sorry, Vishal.
You can pack in any other questions over here. There's just half a minute that's left for us.
Okay, let me check. I think, okay, I'm not sure on this part. It talks about, okay, yes, so, okay, so router can also be added with node or not. Yes, you can add node along with router. So as I mentioned, like when you are talking about hub, it's simply doing the routing function. Now you want to extend that functionality with all other things. Let's say you can add a hub with node or hub with router profile, so that can be done. So your answering your question is yes, router can also be added with node.
Thanks for that. With this, I think we come to end of the webinar. I really thank you all for taking time out. Those questions that we have not taken up, we'll be contacting you separately. If in case you require the deck, do contact us, write us at info@softdel.com, and we'll be sharing the presentation deck with you. Also, we'll be uploading this webinar to our YouTube channel, that is Softdel Systems, and we'll be also sharing on our social media handles. With that, thank you very much for the participation. I hope you do take away things from this webinar. Thank you. Have a nice day.
Thank you so much. Have a good day.
Thank you.